All right, so here we are, 3.4, number 1. We want to write as a single logarithm. Now, these first couple problems illustrate the properties of logarithms, and these are things you learned last year, but you absolutely have to remember now. They're going to make your life easy, believe it or not, if you know how to handle two logarithms, in this case, that have been subtracted. This equals the log of x over y. When you see that logarithms have been subtracted, that means that the numbers themselves, the x and the y, have been divided. Okay, now it's not on the paper, but what do you think this would mean? Then two numbers would be multiplied. If your job is to put two logarithms together, if they've been subtracted, you put them together as a divide. If they've been added, you put them together as a multiply. Okay? And that is exactly the same as we do with exponents. Remember, if things are multiplied, you add their exponents. If they're divided, you subtract their exponents. Okay? Now, problem B illustrates one more rule. Look at problem B, and what do you notice? You notice, I hope, this is going to be a times, that there's a 2 out in front. So here's what you do with a 2. In the magic land of logarithms, that 2 becomes an exponent. So this becomes the log of x squared plus the log of y. So a coefficient in front of a logarithm becomes an exponent. So you simply pluck him off and put him right here. So now I have the log of x squared plus the log of y. So what does that plus sign tell me I'm going to do? I'm going to multiply. What am I going to multiply? X squared times y. I multiply this and this. Now notice that I still have a logarithm, but now I only have 1 instead of 2. And that was my job, right, as a single logarithm. All right, so what do you think about this one? Jose?
I have a question on the last one. I'm not sure if it's interesting, but like, it's just, when you put the exponent into the log, does the same log formula happen after that?
What do you mean?
Like how we multiply and how we add it? Okay, I did that. Yes.
Yeah, so first I take care of the exponent, and then I combine those into one logarithm. Okay, so what am I going to do here? First, I'm going to take care of the exponent. Now, we're not changing it. It is going to stay z to the 1/3. Now, that's a plus. I need one logarithm. What is going to be in that parentheses? Z to the 1/3 times W. Why is it times? Because when you put together an addition, it becomes a multiplication. Every time. All right, what about D? What do you think we're going to do with that one? We're going to write it as one logarithm. So what is the first thing you should take care of? The coefficient. And the coefficient, actually there's 2 of them, right? One here and one here. So this guy is going to become a power. So it's the log of xy to the 4th. minus the log of x cubed. This comes right here. Now what? Make it a division. So 2 logarithms are going to become 1 logarithm. And it's going to be a division because that's a subtraction. And that's the numerator, so xy to the 4th. And that's the denominator.
Oh, okay. So what if does it count if you don't put the, will you subtract the points if you don't put the logarithm in front?
You gotta have the logarithm in front. You're just taking 2 logarithms and writing them as 1 logarithm. You can't get rid of the logarithm. Now, I think we're not quite done with this problem. Because tell me about this. What's this mean?
Y, take,
Isn't that x to the 4th and y to the 4th? Isn't that what that is? And then in the bottom, I have x cubed. And what's gonna happen? You're gonna cancel, and you're gonna end up with just 1x on the top, and none on the bottom? Because you have 4 of them on the top and 3 of them on the bottom? We haven't been able to simplify any of our other problems, but as always, if you can simplify, you need to do it. Okay, now, instead of x's and y's or z's and w's, this next one has numbers. All right, so it's the log of 4 plus the log of 7. Your job is to write as 1 logarithm. That's your job, that's what the directions say. Okay, so you gotta combine the 4 and the 7. They're being added. So when you combine them, you'll combine them as a multiplication. So what goes into parentheses? 28. 28. All right, what about this guy? Again, your job is to combine into 1 logarithm. So that's going to become a division. So it's going to be 16 over 8, which of course reduces to 2. So that's just the log of 2. Okay, try G. Remember, ln is a logarithm, so don't be confused by that. Your answer is going to be ln something. Evan? Huh? You don't have a question? Quit playing with your hair. Looks like your hand's up. All right? What'd you get? ln what? No, not 2. Wouldn't it be 19 over 8?
Yes.
That's not 2. That doesn't reduce. So we just need it ln 19 over 8. Now look at the next one. Back to coefficients. What do we do with the 3 out in front of that ln? It becomes an exponent. So now I have ln 2 cubed. What's 2 cubed?
3.
8. 2 cubed is not 3. 2 cubed is 2 times 2 times 2. That's 8.
Yes.
And then I have ln, whoa, wait a second. What's 36 to the 1/2? What does that mean? Square root 36. And the square root of 36 is 6. So we have ln 8, 2 cubed. ln 6, 36 to the 1/2, square root of 36. And then those are going to be multiplied, so that is ln 48.
Does the number have to go in parentheses?
What?
Does the number have to
It doesn't have to be. I do that because sometimes when I want to remind you that you are going to have one ln or one logarithm and one thing. Not two separate ones, but no, it does not have to be in there. Now, look at part 2. Part 2 is exactly the opposite. Part 2, you are now going to take these things apart. So you have ln xy, and you are going to expand it. So it's going to be an ln and an ln. Now, what's happening with the x and the y? They're being times. So when you pull them apart, it's going to be a plus. So it's going to be ln x plus ln y. Now we're pulling it apart. So remember when you put them together, if it was an addition problem, it became a times. So if it's a times, when you take it apart, it becomes an addition. What happens with the next one? Log x over y. Log x minus log y. That's exactly right. So instead of having one logarithm, now I have 2. How about C? Log x cubed over y to the 4th. What do you think about that one? 3 log x minus 4 log y. Oh my gosh. Are we going to trust Owen?
Yeah.
Yeah. He's right on. Where did that 3 and 4 come from? They are they're the exponents, but the exponents become coefficients. If they start out as coefficients, then we can pop them up and turn them into exponents, but they go both ways, right? Perfect, Owen. Nicely done. All right, what about the next one? Log 5th root of xy. Coefficient of 1/5. Whoa, 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 where's that coming from? Isn't a 5th root the 1/5 power? We're supposed to know that by now, right? 5th roots are 1/5 power. So Dane says, I'm going to pull that one, okay. So this is log xy to the 1/5. So I'm going to pull that off. So 1/5 log xy. Is there anything else I can do? What about that? What am I going to do with that x times y there? I'm going to turn it into an addition. Now be careful. Tell me what's wrong with this. Tell me what's wrong with this. So I pulled that apart and made it an addition. But I need the 1/5 to be on both. Why is the 1/5 on both? Because in the original problem, weren't both the x and the y under the radical? That means they're both part of the 1/5.
Same answer. Like you would accept both of those.
No, this is the right answer. This is the right answer. I'm supposed to be expanding it. So I need 2 logarithms. When it says expand, guys, if you have 2 letters in your problem, you need 2 logarithms in your problem. So this problem had an x and a y. So in the end, I have to have a log x and a log y. If I had 3 letters, I need a log x, a log y, and a log z in my final answer. All right. Log 4th root of x over Z. So tell me what you think about this. I'm listening to Owen again, 1/4 log X minus 1/4 log Z. Now, first of all, do we need a minus?
Yeah.
Yes, we need a minus because this is a division problem. Now, I want you to look carefully at the problem though.
The log Z doesn't have
The log Z doesn't get the 1/4 because, is the Z under the radical? No. So there's no 1/4 this time because that part of the problem doesn't have the exponent. Does that make sense to you? There's no radical on that Z. So therefore he has no exponent. He's just plain Z. Okay? What about L? What's that one gonna look like?
5 log X
5 log
X
X
minus 5 log Y.
Okay, so is Jose correct
You need
in
one.
that both the X and the Y should have the coefficient?
No.
Yes, he is right. They both should have the coefficient. What is not quite right? The exponent shouldn't be 5, it should be 1/5. Because radicals, Jose, are fractional exponents. What you did, Jose, is if it had been x to the 5th or y to the 5th, that's what yours would be. If this is a 5th root, that is a 1/5 exponent. All right? Let's look at the next one. So let's see, you have the log of 100 x squared. All right, ideas. Diego?
Maybe 2 log 10.
Okay, wait a second. Let's back up. Yes, it would be. Let's back up. This is the log of 100 plus the log of x squared. Would you agree with that, Diego?
Yeah.
But then Diego said 100 is 10 squared?
Yeah.
So he said, wait a second, if I write this as 10 squared, then what's gonna happen to the 2? So 2 log 10, that's what he said. And what would this would be? Plus 2 log x?
Oh, I have it.
But we're not done. This one's tricky. This one's tricky. Tell me about the log of 10. What's the base on this? 10? What's the log base 10 of 10 to the first? What does that equal? Doesn't that just equal 1? So this whole thing isn't even a logarithm anymore. This whole thing is just 2 plus 2 log x. Tricky. Tricky. That's an A student problem. If you picked up on that, you're an A. If you didn't, you're somewhere else. Alright, let's see if you can do the same idea. There's another tricky one.
You pick around 8?
Let's see if you can do the same thing with this one. Okay, so who has an idea? No idea. Could you split it apart into anything?
30 plus 3.
So Gabe says ln 30 plus ln e cubed, that was his first step. And he said, I'm gonna pull this 3 off, because it's an exponent. I'm gonna challenge you and say, wait a second, why waste the time? Because what's the base on this?
10.
E.
Jose, that's an ln.
Oh.
That's e. What is log base e of e cubed?
3.
Isn't that just 3? So your answer is ln 30 plus 3.
If we change the ln to log e, do we have to switch it back to ln for our answer?
No. No. You can always rewrite ln as log base e. Okay? All right, now get your calculators out. We're going to do a little calculator work. This problem, 3A, says evaluate the log base 3 of 4. Now, yesterday, remember the last time we had class, we did some problems where you typed in, so like a problem was, log 86.3, and you just pressed your log button at 86.3, and you had your answer. It was easy. What makes this one a little bit different? Evan?
The base
The base is 3. And if you use this button on your calculator, then the base has to be 10. And if you use this button on your calculator, then the base has to be E. So, what do if for some reason we have to evaluate a logarithm that isn't a base 10 or a base E? Well, it is super simple. We're going to use what's called the change of base formula. And it's a formula, but it's so easy. What you do is pick your base. You want to do log or ln, it doesn't matter. Let's do log. So take the log of 4 and divide it by the log of 3. So see how when I wrote this original expression, see how the 4 is kind of above and the 3 is down below? So that will help you remember it's the log of this divided by the log of this. So instead of a base 3, I changed it into base 10. Now, caution, especially on the old calculators. When you do log 4, doesn't automatically put a parentheses there. Close it. You have to remember to close it before you do divided by log 3. You should have gotten 1.2619 as your answer. Now, remember I gave you a choice. I said you want to use log or ln. Everybody just sat there, so I picked a log. What if I did ln 4 over ln 3? Let's try that. ln 4, do not forget to close the parentheses, divided by ln 3. Oh my gosh.
So it don't really matter.
It doesn't matter at all. Okay, it does not matter at all. Use whatever base you want. ln 4.
Yeah, I would put it log 4 first.
Okay. Now, what about letter B? This is a log base 7. So what am I going to type in on my calculator if I want to evaluate this? Log, or ln, 11 divided by log 7. Keep this number on the bottom. See how it's below in the problem? Keep it below when you type in. So log 11 divided by log 7. You should have gotten 1.2323. Right? Someone nod or something? Okay, do the rest of them on, or I guess there's just 4 more. Do those 4, let's see what you come up with. Remember, 4 decimal places. Okay, who can share an answer for C?
Negative 2.7119.
Perfect. Negative 2.7119. Because we took, I don't know if you use log or ln, it doesn't matter. I did log 12 over log 0.4. Right? Okay, who has an answer to D?
0.3263.
Yep. 0.3263? 0.3263? How about E? 1.7959?
Yes.
And what about F?
6.53.
It's 6.4919.
6.4919? 6.4919.
Calculator error. Yep.
Yep. No such thing as a calculator error, just a human error.
Yeah, him it is.
Yep. Alright. So, 3.4 will be due on Monday. And we're gonna start 3.5 and get a few of these done. So put your calculator away. This test is part calculator, part not. I mean, obviously, there are some things we need our calculator for. Problem A, 3.5A. Hey, I know what you're thinking. No, I'm not shutting up. Yeah. 7 minutes, we're gonna use them, so stay focused. 2 to the x is 8. What's x? 3. Everybody should know that, but if not, remember 8 is 2 cubed. So if 2 to the x equals 2 to the 3rd, then x is 3. Now, what about this one? Look at it carefully and think, what might I do first?
Divide 48 by 3.
Divide 48 by 3. Perfect. You gotta get rid of this number, whatever it is. It happens to be a 3 this time, but whatever it is, get rid of it. So 4 to the x equals 48 divided by 3, which is 16. 4 to what power is 16? 4 to the 4th is not 16. 4 to the 2nd is 16. X is 2. Don't make goofball mistakes like that. All right, what about F? Or no, not O. I'm going to C. 4 to the X equals, ooh, this one's a little tricky. like when we got right here, 16 was a power of 4, right? 8 is not a power of 4. 8 is not 4 to the first, 4 to the second, 4 to the third. Jack, did you have an idea?
25?
What was it?
3 over 2.
How did you do that, Jack?
2 squares 4.
Uh-huh. So Jack said, look, guys, 8 is not a power of 4. But both of these numbers are powers of 2. So 4 is 2 squared, and 8 is 2 cubed. In order to do the problem, you gotta make a match. You can't turn an 8 into a 4. That just doesn't work. So you have to change both of these numbers into 2's. So 2 to the 2x, that's a times right there, equals 2 to the third. So 2x equals 3, and you see where Jack got 3 halves?
No. Oh, you can.
All right, let's do one more. Let's do D. D's another kind of tricky one. What's gonna be the first thing you're gonna wanna do? Divide by 3. So we're gonna divide both sides by 3. So 4 to the 2x equals 32. Now, is 32 4 to the first, 4 to the second, 4 to the third? Okay, you can't turn 32 into 4. Not possible. So you're gonna take both of those numbers and change them into 2's. 2's. Always go down. Don't pick a bigger number, pick a smaller number. So 4 is 2 squared. 32 is 2 to the what? 2, how many 2's does it take to get 32?
8.
8. 2 times 2 is 4. Times another 2 would be 8. Times another
It's
2
gonna be
16.
It's gonna be 6.
would be
Five, bro, it's
16. And then
32.
another 2 would give me 32. So how many does it
32.
take? 5.
You said 6, bro.
Where am
I
I?
was off that one.
32 is 2 to the 5th. Now, see how they're both 2's? Now just look at the exponents.
Y'all match.
So that's 4x, 2 times 2x, that's 4x, equal 5. So what's x equal? 5 over 4. Good work. Stop there. We'll pick up there next time. Do I see you tomorrow?
I don't know.
Oh, no, I won't see you till after Thanksgiving. Okay, we'll have a happy Thanksgiving.
I don't know. You can add it to this.
Remember, your 3-4 work is due on Monday.
Sorry,